y prime plus xy is equal to x, and y0 is equal to -1. Y is a real valued function defined on the real line, satisfying the initial value problem above. Then the limit as x approaches -infinity of y of x is equal to 0, 1, -1, infinity, or -infinity. Okay. Yeah, I suppose there's probably a few ways of going about this. You might even solve for the function y of x given this differential equation. But I think given that we're just asked for a limit here, maybe we can reason based off of the ODE what this function has to look like. So y of 0 is equal to -1. And we're trying to find a limit as x goes to -infinity. So let's start by realizing that at 0, when x is equal to 0, if I write down the ODE, I have y prime plus xy is equal to x. Y of 0 is equal to -1. When x is equal to 0, this term disappears, that term disappears. So I have a derivative of 0 at this point. Sketch that little bit. And then x has become negative. So this is now negative. These are both negative, but they're both, this is less than 1. And this, and y is equal to -1 at this point, and x is in magnitude, it's small. So that's a small positive number, and that's a small negative number. So what is y prime? I just want to know if it's going to go in this direction or that direction. In fact, the function might just be a constant. Let's see if the constant function y of x equals -1 satisfies this. So then y prime is equal to 0. No, it doesn't. I don't want to use the multiple choice options as an indicate, like I don't want to use process of elimination. I typically don't in my videos unless as a last resort, although I'm starting to see that there are a lot of ways we could use process of elimination here. I mean, because the constant is not correct, almost certainly -1 will not be the answer. 0, like it, you know, if the answer is 1 or infinity, the function has to cross through 0. So we would need that. Anyway, you can see there's a lot of arguments for why process of elimination might actually work for things here. I'm sort of confusing myself with, signs of things and so on. I think I might just go ahead and solve this equation rather than doing all this trying to argue by sketches of graphs and so on. Okay, so I get 1. And instantly I see another way of doing this. If we just take the original ODE, this is a bit of an ad hoc way of doing it. It's not, maybe not the most rigorous, but if the limit, if I take a limit as x goes to negative infinity, and that's finite and things are nicely behaved, there's no oscillation or that any kind of thing, then y prime has to be equal to 0. If I set y prime equal to 0, then I have xy is equal to x, and so y is equal to 1. So that would be a very good candidate. That would be a good candidate for the answer. But, you know, that's just assuming that y prime is equal to 0. This finds the values of y where the derivative can be 0. And if the function levels off nicely, then that would be true. But, you know, if the correct answer were infinity or negative infinity, then this would not quite do it. But what I've done here is I've actually solved for the function. I wrote it in terms of k. Y of k is equal to this. I'm not going to check that this actually satisfies the original ODE. I'm going to assume that I've done all of my computations correctly here. And then I just explicitly took this limit. And I get that the answer is 1. So it's nice that these two methods end up with the same answer. And this is option B out of the 5 options that we were given. If I have more to say about this one, or if I do find a mistake and my answer is incorrect, then I'll write something down in the description. Thanks for watching.